Okay, welcome Year 12s back to this next lesson. What we're going to do now is start looking at seasonal data and how we can work with this seasonal data to look at any potential trends. Now with seasonal data, remember we're talking about if there's some sort of fluctuation that is happening consistently within a year, then we can say that there's a seasonal component. So this might be, say, a peak every December, or sort of a drop during winter or something like that. There's lots of different time periods that we can use. It doesn't have to be necessarily looking at summer, autumn, winter or spring. Once you do recognise you've got a seasonal component to your data, what you might be able to do is deseasonalise it. And what deseasonalising does is it removes that seasonal component. So if it's coming up and down and going up and down and up and down, etc., we can actually, by deseasonalising, in exactly the same way as smoothing would do, is to reduce these peaks and troughs so that we can see if there is a general trend happening in the data or not. Okay, so what do I refer to when I say seasons? Not necessarily summer, autumn, winter, spring. They can be months, they can be the quarters, or even weeks or days. If you're talking about, say, some takings of a shop or something like that, it may actually be in terms of a week or weeks. What we need to do before we start deseasonalising is talk about this thing called a seasonal index. Sorry, index is singular, but if you're talking about many of them, plural is indices. So what are we talking about when we find a seasonal index or seasonal indices? What it is, it's a number that's going to correspond to each of the time periods that you have in your seasonal data, and what it is a comparison. It's a comparison of the data that you've got for that month or for that day. How does it compare to the average? How does it compare to the seasonal average for that year? So if we've got a value of 1, it means that we've got the average, which the value, that the data value that you've got is the same as the average. Generally, our seasonal index or our seasonal indices, they'll be slightly above or slightly below 1. And you'll see that in this example underneath. We've got some seasonal indices for January through to December. So notice how they hover around about the number 1. So in April, there we have a seasonal index of 1. So that one is the average. When you've got these values, such as January, February, March, and November, December, notice they are slightly above 1. That means they're above the average. Anything that's below 1, so these ones here from May through to October, they are below the average for that year. Okay, we'll talk more about that in a moment, but first of all, a couple of main things when it comes to seasonal indices is that if you add them together, it'll always equal the number of seasons. So if we have a look at this data here, we've got 12 seasons because there's 12 months. So if we add these numbers up, you can do that on your calculator now, pause it and do it if you wish. If we add all of these up, you should find that it does equal 12, which is the number of seasons, which is in this case months. The other thing about seasonal indices, if we take this one step further, once we add them together, if we divide by how many there are, which is 12, so therefore take the average of the seasonal indices, we will always get 1. And this makes sense because if you add up the seasonal indices, you should get the number of seasons, and then you would divide by the number of seasons you had. So it's always going to be the same number, top and bottom, which is simplified to 1. What we can do is answer questions. Knowing these facts here, or mainly this one, the sum of the seasonal indices equaling the number of seasons, we can work out questions such as this one. What's the seasonal index for winter? So this one that's missing just here. So how many seasons have we got? In this example there are 8 altogether. If we add up these ones, all of these ones together, the sum of those, we get 6.8. Now, knowing that we have 8 seasons, we know that when we add them together, we need to get 8. So 6.8 plus our seasonal index for winter, that's got to equal 8. So knowing that, we can go 8 minus 6.8. So the missing one must be 1.2. And there we go. We can do questions such as the one below as well. This time we have 2 that are missing, but these 2 are the same. It says that here. What are they if they are the same? So if I add up these ones here, the sum of those is 5.4. How many seasons are there? There's 8 seasons. So if I go 8 minus 5.4, that it would give me 2.6. And as they are the same, I can divide by 2. So both of these must be 1.3. So questions such as that come up. So you might have a table with one seasonal index missing. So what we would need to do is add them together and work out how much more do I need to add on to get the total number of seasons, because the seasonal indices summed together will always equal the total number of seasons that you have. Moving on, let's have a look at how we interpret the seasonal indices. So here we have seasonal indices for 4 different seasons in 2009. That's why it's got the 09 underneath. So this is what it means. If you've got an index of 1, remember I said an index of 1, it means that it matches, or it is exactly the average, matches the average. You don't need to write this down because it's actually written down here. Seasonal index for spring tells us that the data value, it matches the quarterly average. Now, if you've got something below, see this one here is 0.6. So to work out how much below, as a percentage, how much below the average is this? Well, how much below 1 is it for starters? Below 1, it's 0.4 below 1. So that's just 1 minus 0.6. And if I convert that to a percentage, times it by 100, I get 40%. So it's actually 40% below or lower than the quarterly average, which is what this sentence is. The seasonal index for summer says that the summer, it says summary, it should be summer, figure for summer tends to be 40% lower than the quarterly average. So have a look at how much below 1 is it, and then convert that to a percentage. The autumn and winter, these ones are above, because they are above 1. How much above? Well, this one here is 0.3 above, and that equates to 30% higher. If I wanted to do this for winter, so I've just explained that one. If I wanted to do it for winter, this one, it's 0.1 above the number 1. Therefore, it's 10% above the average. Okay, just as a little summary, here's your seasonal index. If you've got 1, it matches the average. You might like to write that. Matches the average. 0.85, therefore 0.15 below 1, which is the average, which is 15%. And as you can see, that's what we've done with this one as well. 0.23 above 1, and that is 23% above. Okay, so that's how we interpret our seasonal indices. Now let's have a look at how we actually find them. This is how we calculate a seasonal index. What we need is our original data value, and we also need the seasonal average. So we need to look at the average for that year. Okay, so first of all, what we'll do with this example, we've got monthly data to start off with, so therefore 12 seasons altogether, 12 months. What we must do first is find the average. So therefore, we need to add all of these together and we need to divide by 12. You can do that on your calculator. What you should get is, I'll do it on the or just below. I think the sum is 1368. And if we divide that by 12, up into this box here, our monthly average is 114. Okay, now that we've got our monthly average, that seasonal average, we've got that bit there that I've just marked. We have the original data values, we've got them for each month, as you can see in this table. So therefore, to find for January, and you'll notice that this is already written here for you, to find the seasonal index for January, I take the original data value for January, I divide it by the average, which is 114, and if you do that, you get 0.982 to 3 decimal places. If we do that for February, notice 108 divided by 114 over there. 108 divided by 114 is 0.947 to 3 decimal places. What I want you to do is find the seasonal index for each month. So I'm going to copy those first two across. And next we need to do it for March. So 130 divided by 114. Notice when you've got a number that is higher than the average, you should get a seasonal index that is above 1. April, 132 divided by 114. May, 110 over 114. $128 over 114. If you continue this, you should get these values. Might be a good idea to pause it, do it yourself first, and then check your answers. Should be a decimal in there. Nearly there, 1.096, and finally 0.632. Okay, so there are our seasonal indices for that year. Now, what we can do is a check, because we need these to add up to 12, as there are 12 seasons. And if you do that, I think you get something like 11.999, which works. There will be rounding, because we've rounded to 3 decimal places, sometimes it won't be exactly 12, but you can see that it rounds to 12. Okay. Moving along, you can have another go. This time we have quarterly data over 1 year, and this is for some sales. So this is 2010 sales. We've got the raw data, so this is, I'm assuming in dollars obviously, for summer, autumn, winter and spring. Okay, what we want to do is find, first of all, the quarterly average. We're going to add these 4 values together, and then we are going to divide by 4, as there are 4 seasons. So 1183 is what you get when you average those 4 values. Next, let's work out the seasonal index. First, for summer. We take the original value for summer, there it is there, and divide by the quarterly average, so that's where these 2 values have come from. I'm just going to get rid of that because it makes it a bit messy. When you do that, you get 1.098, which is written down there. Let's do that for autumn, winter, and spring. So for the autumn seasonal index, 1324 divided by 1183. Let's round to 3 decimal places. We get 1.119. For winter, 1450 over 1183. 1.226. For spring, 659 divided by 1183. You'll notice spring is much lower than the average, so we're going to get a number below 1. There we go. Again, you can add them up and check that it adds up to 4. It should. So that was just for 1 year, but sometimes we can have data for more than 1 year. And what we're actually going to do is we're going to find the seasonal index for each quarter, and that we do that by finding first the quarterly quarterly average. The average for each year. So the yearly average, and then we would find the seasonal index for each one. Then we would finally average each quarter, each season out, so that we would get a final seasonal index. That sounds like really complicated, but what we're going to do is just one step at a time. So first of all, let's have a look, because we're suspecting that it's seasonal data, obviously, because we're dealing with seasonal indices. But if you look at it on a graph, it confirms that it is seasonal. If I just zoom in a little bit, have a look at where those peaks are. They are at, down here, 3, 7, and 11. So 3, 7, and 11. So that's happening every 4 quarters. And where are the lowest points happening? We've got 4, 8, and 12. So that's happening every 4 as well. So we can see that this is seasonal data. Okay, so let's calculate, first of all, the quarterly averages. We need to do that first. So we've already done this for 2010. That's the same data that we had above in that first example. So now we're doing this for the previous 2 years. So for 2008, let's add up 920 plus 1085 plus 1241 plus 446. What we should get, and you divide that by 4, is 923. Let's do the same for 2009. Add up these 4 values here and divide by 4. 1028. Okay, next we need to get the seasonal index for each quarter. Summer has already been given to us. How do we find it? Don't forget, we take our original data and we divide by that quarterly average. Original data divided by the quarterly average. So for summer, this first one, that would have been 920 divided by 923. And that gives me 0.997. You can see it's just below 1 because it's just below the average. For 2009, 1035 divided by 1028. You'll see it's just above 1 because 1035 is just above 1028. And that final one we've already calculated. That's the one that we did in the first example. So, considering that we already have the seasonal indices for 2010, let's copy them down. So here they are up here. So these 3 values need to come down into this table because it is the same data, 1.119, 1.226, and the last one was 0.557. Okay, for 2008, you'll need to probably pause here and have a go first yourself. I'm going to put in all of the values that I've calculated. So this first one, 1085 divided by 923 for this one, for autumn. We should get For winter, so 1241 over 923. For spring, 0.483. You can see it is considerably lower than the average, so it will be much, much lower than 1. Here we have 2009 for autumn, 1180 over 1028. So it is above. So 1.148. For winter, 1.323, and for spring, 0.526. Okay, so we've completed our seasonal indices for those 3 years now. What we need to do to get our final seasonal index is we need to average these. So to get summer, to get this one here, if you have a look, those 3 values divided by 3. So 0.997, there it is there, plus 1.007 plus 1.098. Add them together and then divide by 3. And we're going to get a final seasonal index for summer. Do the same for autumn, winter, and spring. So add these 3 for autumn together, divide by 3. Do the same for winter and for spring. Okay. Using these, we're now going to interpret those. We're now going to interpret the seasonal indices that we've got for each of these seasons. So, seasonal index, firstly, of 1.03. Notice it's just been rounded to 2 decimal places. A seasonal index of 1.03 for summer tells us that the sales in summer are typically 3%, and they are above. How do I get that? Well, 1.03, that's 0.03 above 1. And if you times that by 100, we get 3. So it's 3%. Now, if we do that for the next one, first of all, let's check. It's talking about autumn. So a seasonal index of 1.148 for autumn tells us that sales are typically 15%. So 0.148 would round to 0.15. 15% above or below, well, it's above 1, so it needs to be above the quarterly average. Moving along, this sentence here is talking about winter. So if I look at winter, 1.298, seasonal index of 1.298 for winter tells us that sales in winter are typically, they're above, they're about 0.30 if I round to 2 decimal places, so 0.30 above, that equates to 30% above. The quarterly average. And finally, this must be talking about spring, because that's the last one that we haven't done. Seasonal index for spring, and I'll just double check what was it. It was 0.52 to 2 decimal places. I'll just go 0.522. Tells us that sales in spring are typically how much below the quarterly average. Well, I need to see how much below 0.48 below 1, therefore it's 48% below the average, which is very low. So that was expected because we looked at the values for spring and they were much lower. If you look at the original values, look at spring. Really low compared to the rest, therefore below the average. So it's not surprising that we get a result like this, a seasonal index. We would expect it to be much below 1, and how much below 1? We look at how much, what proportion it is below, which is 0.48, and then we convert it to a percentage. So that's how we do our interpretations. What you can do now is obviously go back to anything that you haven't filled in and pause the video so that you are able to fill it in. When you have done that, I would like you to start 7D. You won't be able to do all of it just yet because we haven't started deseasonalizing just yet. We've just looked at seasonal indices. So 7D, just questions 1, 2, 5, and 6, and I would like that done before the next lesson if possible, because after that what we're going to do is look at deseasonalizing. So we're actually going to use these seasonal indices to start to smooth out the data so that we can see if there are any trends.